Okay, what about negative radicals? Here's the funny thing about negative radicals, is that the whole concept about how square roots are built upon, trying to take the square root of negative numbers and get a real number as an answer is just simply impossible. You take a look at the first one, for example, the square root of negative 150, you try to do that, and here's what happens. Square root of negative 150, we end up saying an error, and it's a non-real answer. That's right, this answer does not exist on that real number line that you see up on either side of that white screen there with the number lines, right? There is no number on that number line that when you multiply it by itself, you end up with a negative 150 because, as you guys all know, positive times positives give us more positives, and negatives times negatives gives us more positives. So what do we do in these situations? Well, this really bothered mathematicians. This bothered mathematicians so much that they wanted to create a system to indicate that this answer has no place on the real number line and define another whole number system based upon this fact. Okay? So, here's what they decided to do. They decided to look at that square root of negative 150, just like the square root of negative 16, the square root of negative 98, and the negative square root of 116. Take a look at what they did here first. Let me do all of this at once. Take a look at each one of these ones here. Now, if you look at the first one, number 1, negative 150, they noticed that if you broke apart and factored out the negative 1, the whole negative 1 is really what makes the number negative anyway. And if you take a negative 1 and factor that out of negative 150, you're left with a positive 150. And that positive 150, just that positive 150, could be factored into 25 times 6. Seems pretty straightforward, doesn't it? At least it does to me anyway. And then realize you do the same thing here with just the negative 1 factored out of the 16. There's your positive 16. You have 49 times 2 to make 98, and then multiply by negative 1. 4 times 29 gives you 116, then you multiply by negative 1. But what they couldn't shake, what was unshakable, and what makes a common thread throughout all of these problems here, every single one of them, is that we always had that negative 1 sitting right there every single time. Okay? So when it came to this next step, take a look at this. I did all of them at the same time. They would have taken the square root of 25, got 5. They would have taken the square root of 6, right? And so then they would have kept on writing junk like this. They would have said, well, this would be 5 times the square root of 6 times the square root of negative 1. Or they said, well, maybe we could have written it as 5 times the square root of negative 6. Problem is, it does not exist on the real number line. But there really is no way us mathematicians, that's really small, by the way. I'm sorry about that. Let's write that a little bit bigger. There was no way that mathematicians, it really bothered mathematicians that they couldn't really point out explicitly that, hey, this place, this number, wherever it is, does not exist on this number line of negative numbers and positive numbers, and there was no place to put it. They want some ironclad like road sign, big old billboard, marquee, scrolling marquee that says, "Hey, this isn't real. This isn't real. This isn't real." Okay? So, here's what they decided to do. They decided to say, "Hey, you know what, everybody? Here's a new rule. Every time that we get the square root of negative 1, okay? The square root of negative 1. Let's call that, oops, it's got a different color. The square root of negative 1, let's always call that an imaginary unit, and let's call it I. Using I as a letter can more quickly alert somebody that we are dealing with a non-real answer here. Okay? So when we look at something like the square root of, say, let's go to number 7 over here, 16 times the square root of negative 1. We can simplify that and write that as just 4 times I. Remember, we have the square root of 16, which is a perfect square, and so it would give us 16. Oh, sorry, give us 4. And then we multiply by the square root of negative 1, and the square root of negative 1 would be I. Okay? Same deal over here. Square root of 25 would be 5. the square root of 6, we'd leave that one alone, but then we'd still have that square root of negative 1, which would be I. And so we would write our answer as 5I times the square root of 6. Okay? Square root of 49, 7. Square root of 2, leave it alone. And then we still have I. Do you notice where the I is being placed here on questions number 1, 2, and 8 here? There is an ordering that we follow here in the math world, and here it is. If you end up with that perfect square that's an integer, you always write that guy first. Okay? The positive irrational number, in other words, the number that cannot be written using perfect squares or factored using perfect squares, that guy is always last. Okay? So the perfect square is always first. The perfect square is always first. The perfect square is always first, as you can see right there. And do you see where I kind of fits into this mix? If I is present, I always would go after the integer. After the integer, after the integer. And when I say integer, I'm pretty much just saying yellow, aren't I? Okay? So, here's another way to look at this list over here. See this list of perfect squares? Many math teachers told you to memorize all of those lists of perfect squares up into a certain point. All those ones there in red. Pretty much the only thing that Mr. Cook now is asking you to do is I'm asking you to add one more to that memorized list. And that extra one I want you to add to that memorized list is this guy right here. I'd like you to memorize that the square root of negative 1 is always I. Just like you know the square root of 4 is 2 and the square root of 64 is 8. The square root of 169 would be 13. Okay? I want you to memorize that one just as much as the other ones. Okay? So, let's put this to work and look at a couple more problems. So let's take a gander at this next set. Alright, so the square root of negative 128. The nice thing, what I would recommend you doing is first notice because that number is negative, you are going to have I as a part of your answer because negative 1 will be a part of it. Secondly, let's look at that 128. Just focus on the 128. We can still use the same rules we just looked at the last video, right? 128. Can't have any bigger perfect square than 128, so that rules out any number larger than 128. So larger than 128, that'd be all you guys right there. Let's take 128 and cut it in half. If you take 128 and cut it in half, wait a second, isn't that exactly 64? Ooh, so 64 then times 2 would be 128. So it would make sense to cut apart that negative 128 into 64 times 2 times that negative 1, right? And so then we can take the square root of 64, the square root of negative 1, the square root of 2. What would come first when we write our final answer here? You got it, the square root of the perfect square. So the first thing you write would be the 8, followed by the I, and then the square root of 2. So 8I square root of 2. Okay? Oh, and by the way, anytime you want to pause it and let the students work one of these problems and then check their answer, go right ahead. So here comes, let's look at number 9. See how number 9 is another negative number? Let's work that one. Okay? Anytime you want to pause it, go ahead and pause it anytime and let the students work. So let's check this answer. Negative 79, perfect square that would go into that one. Let me get rid of this other stuff. Having a little bit of problem here with that negative square root of 79. Right, 79, that'd rule out any number higher than 79, so 64, 64, no way, 49, no way, 36, no, because I put you at 72, no way 25 would ever go into 79, 16, I don't think so, pretty sure. Once again, any shred of doubt whatsoever, take that 79 and divide it by 16, but I'm pretty sure this won't work, right? You add a whole bunch of 16s together, your answer is always going to be even, isn't it? And never odd, right? And so we know about those numbers. 9, nope, because we get 72, we'd skip over, go to 81. 4, because 4 is even, we'll never hit an odd number there. So guess what? The only thing you're going to be able to do with that is write that as 79 times negative 1, which means that we have the square root of 79 times square root of negative 1, which really means we can write our answer as I times square root of 79. There is no integer here because there was no perfect square. How about number 4? Hey, wait a minute. Did you notice, hey, that's not negative, so you shouldn't have any I in there. Can you factor that? 68. 4 times 17. Did I pick the biggest perfect square? Yeah, because there's no perfect squares that go into 17, right? So then continuing, there's our answer, 2 square roots of 17. Square root of negative 25. Do you notice when it's a negative perfect square, you shouldn't have any square roots in your answer? That's one thing that some students think that they have to have on these problems, is they think that your answer always has to have a square root in the answer. That is absolutely false. When you're dealing with a negative perfect square, your answer will not have a square root symbol in it. Okay, and that's okay. So, I'm going to stop the video right here. I think I've given you enough ammunition to help a little bit when it comes to seeing one problem that you will see in the lesson videos of 5-3. Once again, I want to bookend these two first prologue videos by saying very rarely will you run across a problem this complicated that'll ask you to do this type of work, but don't be surprised on some homework problems. Some homework problems might require you to go to this level of depth because on some of these homework problems you're going to have to use this guy right here, right? The opposite of b plus minus the square root of b squared minus 4ac, all divided by 2a. That's the quadratic formula. And suppose you did the quadratic formula on a problem. And suppose this happened to you. Suppose you end up in a situation that looks like this. You end up with, say, I don't know, 4. And then plus minus the square root of negative 32 divided by 2. What I would fully expect you to do now, which I did not expect you to do in Unit 4, is now I am expecting you to be able to look at that negative square root of 32 and be able to break that down into a positive 16 times 2 times a negative 1 divided by 2. Be able to write that as 4 plus minus square root of 16 would be 4. Square root of negative 1 would be I. And then you'd have the square root of 2 left over, and then divided by 2. And then guess what you can do here? You can reduce this fraction, and because really this guy right here, this 4, and then after the plus minus sign, this 4i square roots of 2, both of those two guys are being divided by 2. Now here's how you successfully reduce that fraction, is you take that blue 4, divide it by that red 2, which would give you 2. Then, here's the only other thing you get to do here, and this is nice. You don't have to do any extra fancy division here. Pretty much you only just take the integer that's right there, that 4, divided by 2. You'll get another 2, and then you'd still have another I, and that's square root of 2. And that would be the most reduced answer you could possibly get. So occasionally you're going to run across that. Look for that on 5-3 when you see that in the next video notes. Okay? Now this worksheet that is put in front of you is not homework. You don't need to do this for homework. However, if you want to check solutions, go to my website and there are full solutions to all of these problems. Okay? Good luck on 5-3.